Hello friends, this video on coordinate geometry part 3 is brought to you by examfear.com. No more fear from exam. Before watching this video, please make sure that you have watched part 1 and part 2. We'll take one example. We have determined if the points 1, 5, 2, 3 and minus 2, minus 11 are collinear or not. So to determine the points are collinear, there are two approaches actually. The first approach is if there are 3 points actually, let's suppose there are 3 points. If you can prove that the area of triangle drawn by these 3 points is 0, that is 1, 2, 3 are same. That is one approach to prove that they are collinear, but we have not learned area of triangle till now, so we cannot use this approach. Or what we can do is, if we have 3 points 1, 2, 3 actually, they are collinear, that is they line in the same line. So what we can do is we can prove that, let's suppose distance between, there are 3 points 1, 2 and 3, let's suppose. The distance between 1 and 2 plus distance between 2 and 3, if that is equal to distance between 1 and 3, that is they are collinear. See, if the triangle is not collinear, if the lines and points are not collinear, it will form triangle. So in that case, distance between 1 and 2 and distance between 1 and 3 will not be equal to distance between 2 and 3. This is different, correct? If you add this and this will not be same. But the moment you talk about a straight line, distance between this and this point 1 and 2 plus distance between 2 and 3 will have to be equal to distance between 1 and 3. Correct? So what approach is, we can just find the distance between points and then we can tell whether they are collinear or not. Correct? So what, let's suppose assume this is point A, this is point B and this is point C. So instead of drawing in a Cartesian form, we can draw that approach also. We can get a Cartesian graph and we can exactly plot this point and then try to find distance. But that won't make sense because unnecessarily we will be wasting our time. Without this also we can solve. Just assume that these are point A, B and C. Now distance between point A, B. You are. So let's suppose this is x1, y1, x2, y2, x3, y3. So I'm talking about point AB. That will be nothing but root over x2 minus x1 square plus y2 minus y1 square. And the whole thing is in root. This will be distance between point AB and that will be nothing but root over x2 is 2, x1 is 1 minus 1 square plus y2 is 3, y1 is 5 square. That is nothing but root over 1 square plus 3 minus 5 is minus 2 square. That is root over 1 plus 4, that is root of 5. That is my distance between point AB. Let's find distance between point BC. Distance between point BC is nothing but root over, this is by taking point B and C, we'll take x3 and x2 this time. That is nothing but x3 minus x2 square plus y3 minus y2 square. Please note it is y3 and 2 here, this is 2 and 1, why 2 and 1 this time? Because we are taking point AB. So A was x1 y1, B was x2 y2. Since here we are talking distance between point BC, we'll take these 2 points B and C. In C we had 3 and 2, so we'll take 3 and 2 is equal to root over, what is the value of x3? Minus 2. What is the value of x2? 2 minus 2 square plus y3 minus y2, that is y3 is minus 11 minus y2, that is 3 square, correct? That is root over minus 4 square plus minus 11 minus 3, that is minus 14 square, that is nothing but root over 4 square is 16 and minus 14 square is nothing but 196 and that comes out to be root of 6, 6, 12, 1, 2, 1, 2. That is the distance. Similarly, let's find the third distance, that this is AC. Distance AC. What we have done? Distance AB, AC and BC. Only three possible distance from 3 points. So AC is nothing but root over, this time will be A and C. A is x1, y1, C is x3, y3. So it will be root of x3 minus x1 square plus y3 minus y1 square. See, don't get too much confused. X3 minus x1 square, or we can also say x1 minus x3 square. One and the same thing, because once you square, the negative sign goes off. Correct? So this is nothing but root of x3 minus x1. x3 is nothing but minus 11. Right? x3 is minus 2. x3 is minus 2. x1 is 1. So minus 2 minus 1 square plus y3 minus y1. Minus y3 is minus 11, y1 is minus 5, y1 is 5 actually. So this becomes root over minus 3 square plus minus 16 square. This is nothing but root over 9 plus 16 square is 256, and that is root of 260. Now we have three distance. We have three distance. The distance are root 5, root 212 and root 265. By any ways we can't say that sum of any two is equal to third. If we take root 5 and root 212, the sum is not root 65. If you take these two, now the best part what we should do here is, so you take the maximum distance, that is 265. So if you see 265 is not equal to root 265 is not equal to root of 5 plus root of 212. Since this is not equal, we are say that they are not collinear. Very simple, just find distance between our points. Take the maximum distance, because the maximum distance has to be equal to some of the other smaller distance. If the maximum distance is not equal to some of the smaller distance, we can say that they are not collinear. Let's take one more example. We have to check whether 5 minus 2, 6, 4 and 7 minus 2 are vertices of an isosceles triangle. To prove that, what we can do is, let's suppose this is a triangle with side A, B and C. If we can find distance of all these sides A, B, A, C and B, C, and then we can somehow prove that two sides are equal, then we can say that they are sides of isosceles triangle. So let's this be point A, B and C. That is, A is nothing but 5 comma minus 2, B is nothing but 6 comma 4 and C is nothing but 7 comma minus 2. Correct? And these points be x1, y1, x1, y1, x2, y2, x3, y3. Now if I am talking about distance between AB, that is AB is nothing but root over x2 minus x1 square, x2 minus x1 square plus y2 minus y1 square. Correct? Distance between point AB. This is nothing but x2 is 6 minus 5 square plus y2 is 4, y1 is minus 2, 4 minus 2 square. Correct? So this comes out to be root of 1 square plus 6 square. That is root of 37. That is my AB. Root 37. Let's find AC. So AC, in this AC, if you see, the points are x1, y1, x3, y3. So this will be root of x3 minus x1 square plus y3 minus y1 square, and that is nothing but root of x3 is 7 minus 5 square plus y3 is minus 2 minus 2 square. Correct? So this becomes nothing but 7 minus 5, that is 2 square plus 0 square, and that is 2. So this is 2. AC is 2. Now let me find BC. So in BC, if you see, the points are x2, y2 and x3, y3. So this will become root of x3 minus x2 square plus y3 minus y2 square. So this becomes root of, what is x3? Is 7 minus x2 is 6 square plus, what is y3? Minus 2, and y2 is 4 minus 4 square. So this becomes 7 minus 6 is 1 square plus minus 6 square, correct? So this becomes root of 1 plus 36, that is root of 37. So if you see here, what we observed is AB is equal to BC is equal to root 37. Since two sides are equal, we can see that this is an isosceles triangle, correct? Very simple. What we have done, we have found the sides, length of the sides of this triangle AB, BC and AC, and then we have seen that the sides are equal, so they are isosceles. Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.